So, hi. Um, this talk is about pushing boundaries. And I want to apologize in advance if it's a bit technical. I try to keep it as pleasant as possible, but we're going to talk about interesting problems, and interesting problems require that we go under the hood. And Emil did a good job in his talk before mine, and he explained some of the concepts that I will rely on. So I'm very happy that his talk was scheduled before. Okay, let's go ahead. First, I want to introduce myself. If you don't know me already, my name is Tal, and I work in Wix.com. Wix is a platform for small businesses to manage themselves, and it all starts by creating a beautiful website. And it's not a small platform. We have over 100 million users. We're big believers in React Native. The Wix app, which you can see here on the right, is written 100% in React Native. We kind of switched all of our mobile efforts from pure native to React Native in the past 2 years. I'm originally a native developer. And being in production with React Native for 1.5 years, almost 2 years, teaches you a lot, and that's really why I'm here. So, performance in React Native, are we there yet? So you know, in software engineering, you always try to find the best tool for the job. And whenever I start creating a new app, I ask myself, is React Native the best tool for the specific use case of this app? And this is a React Native conference, so you're probably asking yourself, is there a use case where this person would not use React Native? And the answer is yes, if we have to be honest. So if I were to write, for example, WhatsApp, or Facebook Messenger, or an instant messaging app, I would not use React Native for that. Why? Because the performance overhead of React Native in this specific use case outweigh the productivity, the amazing productivity boost that this framework gives. And as you know me, I'm obsessed about performance. I do a lot of work in this space, if you've read my stuff. And I know I always ask myself, did we squeeze everything out of this lemon? I mean, do we have more to go? So first of all, there's a test. You know, that's a phrase we coined in Wix, the Pepsi challenge. How do you know if we're there yet? So this is a way that I really recommend you do, is you try to take an app, a very simple one, and try to implement it both times, once purely natively, and once with React Native, and you run it on identical devices and give it to a user. And tell the user, can you find out, just by interacting with the two apps, just by playing with them, can you spot the React Native one? And if you try to do this exercise, you will see that in many, many cases you can. And this means that we're not there yet. And this ties into Gianni's talk from before. We're close, but it's not indistinguishable. And I'm obsessed with that small part. How do we fix that? So it's all about the gaps. So when you do this exercise, you see there are many major gaps that we need to go over. For example, animations. And the community has been doing this for the past 2 years. We've been taking the major gaps and solving them, resolving them one by one. So animations, it was resolved with animated. It's the amazing declarative animations library and the native driver. So now we have animations at 60 FPS. Navigation is also a very big thing that is missing. And I personally don't believe in JavaScript-based navigation libraries. But there are native ones. There is one from Wix, React Native Navigation. There is one from Airbnb Native Navigation. And I think eventually they will mature enough that they will become the mainstream. And this will happen in the course of the next 6 months. Gestures is also a big thing that was missing in React Native. The JavaScript gesture system is not good enough, and it is being re-implemented by Christoph Magiera. He has a very exciting plan of how to do this. And interactions is something I talked about in ReactConf, for example, and I showed a proof of concept of how we can do user interactions in 60 FPS. So there are ways to resolve most of these issues. But are there more? And what I ask my product managing team in Wix, in charge of the app, is to make a list of all the things that they're not happy with our app. And I always go over this list and I see which ones are easy and which ones are difficult. And there are 2 small issues that I want to talk about today that are seemingly very, very minor, but they represent something much, much bigger. So I want to show you these small Jira tickets that I actually have open in our app, and I want to show you what they are. So the first one is we use a native navigation library. So this is a screenshot from our app. And product is complaining, I'm complaining as well because I play with the app, complaining about a flicker when pushing a new screen. And I want to show you what this is. So I took a video in very super slow motion because in regular runtime of the app, you won't feel that, almost. So take a look. You push a new screen. It's white, and then the content appears suddenly. So this small flicker that happens for a few milliseconds is annoying. Why? Because this is a way to distinguish that this is a React Native app. I'm going to show you another seemingly minor use case, and this time with a list view. Okay, we all know that lists are a very core thing in mobile, and smooth lists are like the pinnacle of mobile development. So in our app, we have a complaint from product and UX that there is a flicker when we scroll the list very, very fast. So again, what I did is I did a slow-mo video so you can see what I'm talking about. So look at the cells from the bottom, and they're white, and they're just appearing. So normally, normal usage, you would not feel that because the JavaScript-based lists, like FlatList, which is amazing, have clever ways to hide this problem. How do they hide it? They just do a render window in the bottom, and this flicker happens off screen in most cases. So the user doesn't feel that. So this is a way kind of to hide the problem and ignore it. But no matter if the user will scroll fast enough or if the user jumps to the middle of the list or scrolls to top, you can't anticipate which cells will be required, and then you will have this annoying flicker. This problem actually caused us to take one of the major list views in our app, which is a list view that shows you all the photos on your phone. Okay, you have 5,000 photos, you want to find a specific one if you want to upload it, and this list should be super smooth and fast, and we couldn't implement it with React Native no matter how hard we tried. So there is an issue here, and I investigated this issue, and the first question I asked myself, oh, it seems minor, it seems easy to fix, and apparently this is not the case. Usually the trick that we do for performance problems in React Native, and this was pretty much the trick for all the issues, all the gaps, the major gaps that have been resolved so far, is by going declarative. You do, instead of doing the animations yourself, you declare them and you have a native driver to run them frame by frame. So this is the trick, kind of the tactic that we use for everything. And this tactic doesn't really work here because this seemingly minor issues uncover a very fundamental boundary of React Native. And we are about pushing boundaries, and I want to kind of dig into this boundary and show you what I'm talking about. So let's kind of jump out from this specific use case and talk about a general thing. A general thing, a question, to block or not to block. Okay, this is the question. And every time you have a system that you have two parts of the system and they need to communicate, it doesn't have to be React Native, anything at all, even web communication or server communications. You always need to decide if the communication between them is blocking or non-blocking. This is a fundamental design decision that you need to make. And let's see the differences between them, but I'll put them in the context of React Native. So in React Native, it's the same thing. We have two realms. We have two parts that are constantly communicating with each other. Okay, we have the JavaScript realm and we have the native realm. The JavaScript realm is where you write most of your business logic. Okay, it's JavaScript, it's easy, it's very productive. You write there with JavaScript naturally. And the second realm is the native realm. That's where all the UI sits. The UI is not HTML UI, it's not DOM, it is native views, regular native views that Emil explained very nicely in his talk how it all works. So these native views, in order to implement them, and most of them are implemented for you in the framework, are implemented in Objective-C, in Swift, in Java, in the native languages that are appropriate for each platform. And the communication between these two realms goes over the React Native bridge. Okay, you just send messages, and I think Emil showed exactly how it works. If we go into a little bit of specifics, then the JavaScript realm runs on a thread. There is a thread in your app charged with running the JavaScript code, and there is a different thread. There are many native threads, but the main one is the main thread, both on iOS and Android, and all the UI has to take place over there. So let's take a look at some design decisions that we could make when implementing a system that has the communication between these two parts. So one option is to block. So how would that look like? So let's say we have JavaScript, and the JavaScript is doing some work and scheduling some work, and suddenly there is some work that needs the native side. So what you could do is that when this message A is ready to be sent, then you would block the JavaScript. And JavaScript will not run anymore until the native handles some sort of request or command that you sent over. And then the native side could schedule some work. And then when the response is ready, then JavaScript could continue running, and it would schedule more unrelated work, and then there would be maybe another message. And the same thing would happen. You would wait for the native side to handle it, and then the native will run, and it will come back and return. So this is effectively, you could say, it's running both threads on one thread. This is a parallel. And there are systems built around this concept. Okay? For example, NativeScript is more closely to this than specifically React Native. A different alternative is to do a non-blocking approach. How would that look like? Then you would have both threads scheduling work, which is completely unrelated to each other, and then suddenly you would have this message that you need to send over to the other side, this A message like before. So you queue it in some queue, and the other side is still doing other things because it has its own workload and it's just busy. And you have another message, and it's queued as well. And finally, you see that the native side is ready to handle that. And then this message will be handled, and then the other message will be handled. So this is a different approach for the same problem. And if you had to make a choice, which one of them is better? So the first thing, there is no clear answer. Okay, there are always trade-offs. This is good in some use cases. This is good in a different use case. So it's mostly a strategic choice. And what was the choice that was made with React? And to go back to that choice, we need to go back to the days before React Native, when React was only for the web, and the choice has already been made for us with React. So if you look at how the web is working with the DOM, it's actually the very, very similar problem. You still have the two realms. You have JavaScript, and you have the native realm, which is the DOM. And JavaScript in the browser, by default, is synchronous. Every time you do a DOM change from JavaScript, the JavaScript is blocked until the browser handles this request. So by default, the web was synchronous, was the blocking kind of paradigm. And as you know, there was a big performance gain with React when the concept of the shadow DOM was introduced, and we had JavaScript updating JavaScript, and then the updates would be sent asynchronously in the background. So React made a conscious choice to go the asynchronous way, and it's not a limitation. So React rendering is asynchronous by design, and it's important to understand. Okay, this is not a limitation, but a feature. And this feature works well most of the time. The whole declarative paradigm of React, which is why I personally love maintaining React apps, it's so easy, is because of that concept. Okay, asynchronicity allows it. So it goes much, much deeper than just performance. It's the way you structure your whole code base. And it also allows for some very interesting optimizations. For example, diffing. Okay, we know that the React Reconciler finds the smallest differences between the trees, and it only updates what needs to be updated. So even if you, as a developer, you're not sure what needs to be updated, you just update the whole thing, the system is still very efficient. So this would not work well with a synchronous system. Okay, only asynchronicity would allow that. Another cool feature is batching. You could do a performance optimization that you will batch those changes together and reduce overhead. And this also works only if you have a queue that is batched every once in a while. And the third cool optimization is fiber. Prioritization. You know that not all renders are equal. Some of them are more important than others. Then how can you schedule some of them and give them priority over others when everything is synchronous? So asynchronicity opens the door for that as well. So there are great things with asynchronicity. But there are also limitations that come from this design choice. And I want to show you the list example that I talked about. And I want to show you why this flicker originates from a fundamental boundary of how React works. So let's say that the user scrolls n pixels down the screen in a list. Okay, the exact use case I showed you before. And the right side is the native side in black, and the left side is the JavaScript side in purple. And the scroll view that the user is using is a native view. And it has to redraw the content as soon as the user moves it. And then the user uncovers a new row. And this row is not populated with content yet because of memory optimizations. So there is no choice, but we have a new uninitialized row, and it's white. There is no content there. And the native side has to display something, so it just displays blank space. Now we do want to start generating content, so we generate a scroll event, and this scroll event has to be sent over the bridge to the other side. Why? Because our business logic that will populate the list exists in JavaScript. There's no way around it. That's just the way it works. Now, it's not only the overhead of going over the bridge. The overhead is waiting until the JavaScript side is free. It's doing other things now. It's processing other things. We have to wait until it frees up to handle this request. So once the JavaScript is free to handle, it will prepare the new row. React will render the new row. And once again, like Emil showed, the rendering doesn't do anything. It's just a series of imperative commands that go back over the bridge because the views themselves are native. So this has to be sent again, and then you have to wait until the native side is free to handle this because everything is asynchronous. And only then the native views are created for the row, and the new row is drawn with the correct content. So if we look at this very complicated process and we highlight this part, this is the flicker that we're talking about. This is the white part that takes a while to disappear. And the user can notice it because it's not immediate. We have overhead here that can take a few milliseconds. And this is an inherent thing. Now, you might ask yourself, okay, you told us about the Pepsi test, so you would implement the same thing in native. Wouldn't you have that flicker in native? And the answer is no, and it's actually very easy to achieve. Every simple list in native doesn't have that flicker. And the reason is very simple, because the model there is not asynchronous. The standard model there is synchronous. Whenever the scroll view needs to fetch another row and render it, the same main thread renders the row and brings the content and lays it out and does everything. And the overhead is so minimal that the synchronicity of the thing makes it all silky smooth. So in native, you would have gotten this without any effort. But with React, just because how the system is built, we have kind of work around this huge thing. And so let's talk a little bit about how can we circumvent asynchronicity. And this is something so deep in the platform that is actually pretty exciting to think about. So before we start diving into the details of how this could be possible, let's just go about the API. What API would we give this? So let's go over the basic API of React Native itself, of how React Native connects to native. So in React Native, you have your entire React component tree lives inside a native view called RCT root view in iOS, in this specific example. So if you write a greenfield app, then your entire app is pretty much this view. It covers the whole screen. But if you were writing a brownfield app, and it was already native, and you would want to add a React Native part somewhere, then you would use this view. And from that point on, inside, there would be a React hierarchy. So RCT root view is where it all starts. And let's say I have my app, and all of you have written this code. If you wrote a React Native app, you would have a React component. And there is always a line, if you recall, called app registry register component. And you just write it without really thinking about it. So if you don't know what it does, I'll tell you now. You basically give this root component that you want in your hierarchy a string name, and you just register it somewhere. Okay, where are we going to use it? In a second. So RCT root view is the native view where React starts rendering. Okay, the whole app runs from this view. And the API for RCT root view is very simple, and it has one main command that you need to know. And this command, and this is Objective-C code, I apologize if you're not familiar with the syntax, but the API is very simple. You just create this view, and you pass one main parameter, which is a string, and this is the registered name that we registered in JavaScript before. That's the whole API. It's quite simple. You have this line in your app. You probably didn't write it because the boilerplate you used kind of wrote it for you, but if you look in app delegate closely, you would see this, something very similar to this inside your apps as well. So let's take a look at the second use case. I told you when a user pushes a new screen in our app, we have a flicker. Why does that happen? So let's take a look. The user pushes a new screen. What does our native navigation library does? It creates a new RCT root view. Because our navigation is native and we have a native view controller, we need to push a new React hierarchy to screen. So we create a new RCT root view by ourselves and just specify which component we want. And then, as before, the system, currently it's in the native side because the native push happens in the native realm. And the content is uninitialized. So we have white blank screen, just like you saw in the slow-mo video. And we have some sort of creation event, and this has to be scheduled and sent over the bridge. We have to wait until JavaScript handles it, and then it will init React and the whole root in JavaScript. Okay, the left side in purple is JavaScript. It will render the whole React tree, and then there would be the imperative command that Emil showed us. They would be sent over the bridge, and then we would create the native views in native once again, and we would have the new screen content drawn finally for the user. Once again, if we look, we have this part that is non-negligible. Okay, and it comes from the asynchronicity of the system. And this is the white flicker that I talked about. So, what do we want to do? If we want great API to kind of go around this problem in a very core way, what can we do? So maybe we should have a synchronous root view. So what does it mean, really? So we will give this root view the exact same API. Why? Because we want it to be easy to use. So you would use it in JavaScript in the exact same way. You would define a component, just like you did before. you would use JS6, and we want to use JS6 because JS6 is easy, it's productive. Okay, that's why we use React Native. So you would write your component in JS6, and you would register it just like before, but instead of using app registry, you would use a new registry called sync registry. Okay, it's a special registry, and we'll talk about it in a minute. So in sense of APIs, the API is identical. What would be the native API if you want to use it from the native side? So we would have, just like before, a create method. Okay, that's what we want. But also we want an update props method. And the APIs are identical to what we had before. It's just RCT sync root view instead of RCT root view. And you would just pass on the string of the component that you registered. So all of this is super simple. But what is the main thing here? What is the novel thing? The novel thing is the requirement that this creation and update that originate from the native side, these are native commands, they're going to take place without going over the bridge. We're going to render the native views by staying in native. And this is exciting because this kind of circumvents the asynchronicity of the whole thing. So what would it look like when we push a new screen in a navigation solution? So first of all, we had the JS6. We did the register in the sync registry. And when did this registration happen? It happens when the JavaScript loads. It happens once on initialization. So in initialization, we're going to render our templated component just when we register it, and we're going to render it once because it's JS6, and it's going to be sent over the bridge. There's no way around it. And we're going to do some sort of a magical store recipe for this component. So I'm going to talk later about how it works, but this part takes place on the native side. And this happens on initialization once, and now we go back to when the user does an action. And this action can happen many times. The initialization only has to take place once. So when the user pushes a new screen, instead of creating an RCT root view, we would create from the native navigation library an RCT sync root view instead. And this sync root view doesn't go over the bridge. It magically uses the recipe that it stored before, and it stays on the native side, and then the native views can be created without going over the bridge. And the new screen can be drawn immediately with correct content. So where is the slow part? Where is the part with the overhead? We kind of pushed it to the beginning when the app initializes, which is no big deal. It's an extra millisecond when the app starts, so it's no non-issue in my eyes. And what is the part that we optimized or changed? This part, the part that uses the recipe, it stays on the native side. It doesn't go over the bridge anymore. And this is, I think, the exciting thing about this approach. So the synchronous render, in this case, resolves the flicker. And it's just not only the flicker. I want you to understand that there are certain use cases. It's not the 90%, it's the 10%. The 10% of the distinguishable things are usually because of this fundamental problem. And if we had some way to work around it, it would open up a whole exciting world of APIs, of infinite lists and table views and collection views that could be implemented, and this is the way to tie them back into React. Let's take a look at the list example and how this would handle the list example. So from before, we saw that with the list example with traditional synchronicity of React, we would have the flicker because of the overhead that we had when we render a new row. So what would it look like now? It would be the exact same way. When JavaScript initializes, we would register a synchronous component, which would be our row, our template for our row in the list view. We would render it once. When the app starts, it will be done over the bridge. There's no way around it because it's JavaScript. And we will magically store the recipe for this row natively. And when the user scrolls down the list, eventually, and this, unlike before when you say how many screens does the user push, this happens if you have 5,000 rows, this is going to happen 5,000 times. You want this to be fast. Then you would probably rely on a native list of some sort of like UI table view, your collection view. There are many people who tried to bring those native views to React Native, and it never worked. And the reason they never really worked is it's not that you can't bring them in, you can, but they don't solve the fundamental problems of the asynchronicity. You still have the overhead. But now when you recycle, and all of these native lists are all based on the same concept of recycling old views just to make things fast, then you will use the recipe that we had before, and you would create the views for the row, and you would stay on the native side. So we would call this synchronous. The new row would be drawn with correct content immediately. The slow part is pushed to the beginning, and the part that we had the flicker in disappears because it is now practically immediate. So now we had the magic store, and the magic use. How do you implement those things? So it's actually pretty easy. So the first thing we need to do is to kind of hack the reconciler, to really understand what React does when it renders views. And here is where I'm grateful for Emil for explaining this for a whole talk, what I have one slide for, so I can run over this really, really quickly. I have 5 minutes left. So you would look under the hood and you see what React does. So how does React render native views? We could use this same process just to record our own recipe. And it's actually pretty simple. So let's say we have a simple component that we have, unrelated to what we're talking about. We're just exploring how React works under the hood. And this component has a view with flex, flex style, and a text input. That's it. And as we saw, when React reconciles this in JavaScript, it sends imperative commands over the bridge. And these commands are commands for the UI manager. And you already know what that is. So UI manager is the native module that is in charge of instantiating native views in React Native. And the commands that you would send to it are, let's create the first view, the RCT view. And RCT view is the native counterpart of the view component in JavaScript. And it receives the props simply inside, and it has some numbers. These numbers are the React tags that are allocated for this view. And then it would create another one, the text input. You see that in native, it's not actually a text input, it's RCT text field, and the prompts are a bit different. Instead of value, it's called text, but that's okay. It knows how to translate these things for us. And then it would set children and play with the React tags just to set everything up. So how would we store the recipe? Okay, this is what happens when we run the render function. So we want to do this, I remind you, on JavaScript initialization. So what we would do is we have our sync registry, and we do the register to sync registry when the app starts, right? This is the first line that the app pretty much does. So what we're going to do is, in the sync registry, we're going to manually call React Native.render. I mean, have any of you ran the render function imperatively by themselves? So you can do that. So we're going to run the render function on this template of a component. And what will this do? The render function will result in these messages being sent over the bridge. So what we're going to do now is we're going to swizzle. Swizzle is we're going to stub the JavaScript functions of UI Manager. We're going to replace them temporarily with stubs that instead of a function like create view or set children, we will have stubs that all they do is they record the arguments that were sent and saving them in a JavaScript array. That's all we're going to do. And we're going to store this array, and when we finish the initialization part, before we return, we're going to restore UI Manager and like undo our hack and remove the swizzling of the function. Okay, so what would we turn this recipe of the UI Manager commands that we had to do? We would change it into some sort of JSON. Okay, we would have an array of commands and the names. This is very similar to what is sent over the bridge, actually, but we're just doing it ourselves. And this is now our recipe. And we could serialize this and send it over the bridge on initialization and store it in the native sync registry. Now comes the time to use the recipe. When are we going to use it? We're going to use it when RCT sync root view is created or updated. We said that our main requirement from the API of creating an RCT sync root view or updating its props, it's to do this synchronously on the native side. We don't want to go over the JavaScript bridge. The bridge to JavaScript in that case. So how would that work? Whenever you create an RCT sync root view or update its props, we're going to go over the recipe, the JSON recipe that I showed you, and it's stored. It's just serialized and stored in our registry. And we go over it, and we have the commands that we need there. We can just execute them. We can instantiate. We can call the UI Manager commands natively and instantiate the native views without going over the bridge. So this seems like a magic solution that kind of solves all the world problems, but I want to show you some fundamental limitations of this approach. Okay, so this is not a perfect approach, and the main limitations of it, and I'm hoping that some of you can already guess them by themselves, that this would only work for declarative components, components that don't have any JavaScript code inside. Okay, I'll show you an example in a second. Okay, so you can't have, for the rows in your list, for this specific performance boost, you can't have any JavaScript code in there. It's just a declaration of components, calling components and passing down props. That's it, and this is a severe limitation, but sometimes you have to pay for the performance. And the prop updates that you do can't alter the tree. You can't have components in the tree disappearing and appearing, rendering or not rendering. All of them will be there because they're part of our recipe. So I have like 20 seconds left, so I'll show you an example. What happens when this limitation is what blocks you? Okay, I need some JavaScript code. So let's say in my cell in the list, I have some JavaScript code, like in this example. Okay, I want to render hello or goodbye based on a prop, which is a Boolean. What would you do in this case? So there are ways to work around most of the cases, I think, and it's especially true for lists, because lists that are repeating and have the same cell over and over, if you think about it real hard, you see that they don't usually require a lot of JavaScript code inside. So what would you do? It doesn't satisfy the limitations that we talked about before, but you could just change the props that you have. So for example, I would define new props, and the new prop would be display high and display by, instead of just having a Boolean called isHigh. And the values of these props would be flex and none, because I don't want the business logic inside. I pushed the business logic to the props. Okay, so the part of my code that creates all the rows for the list view and handles the data, it will create this transformation for me when I create the data set. And then our component is simple. It just has the two different text components, and we just pass the props directly to display. And React Native currently supports display none. It's a relatively new feature. It has been committed already. And you could say that if you want to display high, you just pass flex to the first one and none to the second one, and the second one will disappear. And this is completely declarative. Okay, there is no business logic here, and this works under our requirements. So you can see a proof of concept of this working. Okay, you have a code with the whole thing, with a synchronous root view. It's available in the Wix GitHub account. You can take a look. I'll publish the slides a little bit later. And thank you. I think we're out of time.